Alright, Unit 4, solve algebraically and graphically. So let's go solve algebraically first. So they're both set equal to y. So I'm going to use substitution. So since they're both equal to y, they're equal to each other. And then I'm going to subtract 3x to both sides. Alright. I'm going to add a 6 to both sides. Alright. Divide by 2 and x equals 2. Then I'll go back and plug in, I don't know, I'll plug into this one up here. Okay. So they cross at this point right here. Okay. Then I'll solve these graphically. So let's do y equals mx plus b. Start at -2. Go up 3, 1, 2, 3 to the right, 1, 1, 2, 3 to the right, 1. Okay. And this one start at -6, 1, 2, 3, 4, 5, 6. Up 5, 1, 2, 3, 4, 5 to the right, 1. Okay. And we're looking at about 4. Okay. You can see the cross of the point 2, 4. Okay, on to the next one here. I'm going to set these up on top of each other. Solve it algebraically. I'm going to go ahead and eliminate the x's. So I'm looking at -2x minus 4y equals -14. Sorry, that should be a positive x. Sorry, positive 2. So let's do all these positive. Sorry. Multiply by a positive 2 to get rid of the x's. That's negative. Plus y 6. Okay. And then I get 5y equals 20. Divide by 5 and y equals 4. Okay. Go back and plug in. I'm going to plug into this one right here. So I'm going to get x plus 2 times 4 equals 7 plus 8 equals 7. And x equals -1. Okay, so let's go back and solve these by graphing. So taking this one here, and then I'll solve for y. Okay. So 1, 2, 3, 4, 5, and 6, and then it's going to go up 2 into the right 1. Since I can't really, I'm going to go the other way. I'm going to go down 2 and back 1 to the left. Okay. Then I'll take this one over here and solve this one for y. Subtract x to both sides. Alright, divide by 2. Get y equals -1/2 x. So I get 7 divided by 2, which is kind of a pain. Just to make for the graphing purposes, I'm going to just make it a fraction. Sorry, a decimal. So plus 3.5. Okay. 1, 2, 3.5, and then down 1 to the right 2. Look here. And you can see they cross at the same point. Okay. All right. Going down here to the next one. This is an inequality, so I'm going to go ahead and solve it for y so I can get the line put up there. Divide by a negative here. Okay. So I got to flip my inequality sign. A negative divided by a negative is a positive, minus 5. Okay. So let me get a couple points here. So -5, 1, 2, 3, 4, 5. Up to the right 3, 1, 2, and 3. Okay. So this is just less than. There's no equal sign under there, or equal to. So this is a dashed line. Okay. The y's are less than the line, so I'm going to shade underneath here. Okay. So basically, any point in that shaded region will work. So this is the list sum. I'll just put it 1 in there. 1, 2, 3, 4, 5, 6. 1, 2, 3. So 6, -3 is in the shaded region. All right, and so is 1, 2, 1, 2, 3, 4, 5. So 2, -5. Now you just got to find something in the shaded region. So now I'm graphing inequalities, a system of them. So let's see here. So this, they're already solved for y. So +5, 1, 2, 3, 4, 5 is my point. I'm going to go down 3, 1, 2, 3 to the right 1. That's a solid line. Okay. And it says the y's are less than, so I should shade under the line. So I'm basically going to shade all of this. So I'm just going to leave it kind of real light. And then I'm going to graph this one, -3, 1, 2, 3, up 1 to the right 2. And this one is a dashed line. Okay. And this is the y's are greater than, so that means all the stuff up above it, so all of this side. So that would shade everything up here. All of this region up here would get shaded. Everything up there, basically. So the answer is going to be in this realm right here. So anything in that area. Choose 3 points. So like 0, 0 would work. 1, 0 would work. Okay, any point in shade. Then they're going to ask us, are the following ones? So let's just do a couple. 0, 0. Yeah, that's a yes. 0, 6. 1, 2, 3, 4, 5, and 6. So that's a no. And you would just have to go through and plot all those points and see if they are in the shaded part. Okay. The next one here. State Fair is a popular field trip. This year, the senior class of ABC High School and the senior class of XYZ High School plan their trips there. Senior class ABC has rented and filled 8 vans and 8 buses with 240 students. So we've got 8 vans plus 8 buses is equal to 240 students. XYZ has 4 vans plus 1 bus, and they have 54 students. Okay, find the number of students in each van. So how many kids can go in a van? So got my system set up here. I'm going to go ahead and multiply this one down here by -2 and get rid of the v's. Okay. So I'm looking at 8v plus 8b equals 240. -8v minus 2b equals -108. Then combine my like terms and I get 6b, and then subtract those, 132, and if I divide everything by 6, b equals 6. So there's 6 people in a bus. Okay. So now I got to find out how many are in a van. So I'm going to plug into this one right here before I multiplied by -2. So 4v plus 6 equals 54. Subtract 6 to both sides. Right? Equals 48. So 12. and x equals 12. Well, in this case, sorry, it was v. Sorry, it was a v. So 12 in a van, or how many they had of each. Okay, next one. Cell phone company offers two different plans. Plan A is $40 per month as a flat fee, no matter how many minutes you use. Okay, so that's just going to be y equals 40. Plan B, customers is $15 plus 10 cents for each minute used. So that's going to be y equals 0.10x plus the 15. That's what I start with, right? That's my y-intercept. Create an equation, okay? And graph both. So I got to get all the way up to 40. So if I go 5, 10, 15, 20, 25, 30, 35, 40, 40. Yeah, we'll just go by fives. So there's no negatives I got to worry about. So here's 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, that's money, that's cost in dollars. And down here we're going to do minutes. Okay. So for one of them it's just 40 no matter what. So if I go to 40, the bill is always 40. Okay. There's one equation right there, y equals 40. And the other one is 15. Okay. And up 10 cents over 1. So looking at this, so that would just be right about here, and that's going to go up like this. It's not a real accurate graph here. Okay. So what I'm going to do is I'm going to solve this kind of by plugging stuff in. I think is a better way to do it. So which is cheaper? Okay. So I'm going to plug in. Now remember, this is going to be x. So up here it's $40 no matter what. So I'm going to plug in 200. Okay. So 0.1 times 200 is 20 plus 15. Okay. And y equals 35. So for that case, plan B is better. It's cheaper. Okay. Okay, looking at our last page here. Alright, so A, B, and C are solutions of f of x. So here's f of x right here. That's this line. And A, B, and D are on there, so that is true. Okay. B is the solution of where f of x equals g of x. Yes, that's where they cross. C is the y-intercept of f of x. So here's f of x, and the y, that is false. Okay. D is on f of x right here when f of x is greater than g of x, meaning it's on top of it. Okay. So you got to look at where they intersect. So I'm just going to kind of look at this side. So right here, f is bigger because it's on top. So is that true for D? And that is true, yes. Okay. E is the x-intercept of g of x. So here's g, and there's e, so that is true. A is on f of x when f of x is smaller. Okay. So f of x is smaller. If I rewrite this. Okay, on this side of where they cross, B. Okay, it's smaller. So is A, yeah, that is true. Okay. Coming down here, okay. There's an infinite number of points and solutions, even though there's only 3 points labeled. Okay, statement true or false. Okay. F of x is less than g of x when x is less than 1. So here's x is right there. So I can write this on both sides and see it. Okay. when x is less than 1, that means I'm going to go here, x equals 1, everything to the left. G is the bigger one, f is the smaller one, that's what they said. So that's true. Okay. F of x is less than g of x when x is greater than 1. That's on this side. And if you look here, f of x is bigger, right, because it's on top, so that one is false. F of x is greater than g of x when x is greater than 1, so x is greater than 1 is on this side, and that is true. F of x is greater than g of x when x is less than 1. That's on this side over here, and that is not true. That side, the g is on top, so that's bigger. Okay. F of x equals g of x when x equals 1. So here's x equals 1 right there, and yeah, that's where they cross. So that is true. And the last one has to be false if the one above it is true. Okay. All right, here we go. Last one down here. We're going to solve. I'm going to go ahead and use elimination. So I'm going to multiply and get rid of the y. So I'll multiply this by -4. So rewriting what I get. Okay. Negative 12x minus 4y. Right, so that's at 208, I believe. 204, sorry. And that's negative right there. Okay, those cross off. Right. And I get 7x, that's negative. And then 204 minus 8 is negative 196. Okay. And x equals 28. So now go back and plug that in. I'll go ahead and plug it into the top one there. Okay. By that times 5. That's 140. Then I'll subtract 140 to both sides. Negative 132. Right. And then divide that by 4. Y equals negative 3. And they would cross at the coordinate point 28, negative 33.